Hello everyone, my name is Amir Mahdiyar and I will be presenting our research on hindrances to adoption of green walls, a hybrid fuzzy-based approach. Green walls have been considered as a part of green infrastructure and also a nature-based solution to the current environmental issues. Green walls contribute to every aspect of sustainability and offer several environmental, social, and financial benefits, such as energy saving, improving air quality, and reducing the urban heat island effect. The extent of these benefits depends on several factors, such as the climate in which the green wall is installed, the regular maintenance, and types of plants used. In our research, our focus is on Hong Kong as a perfect place for green wall installation due to having a high number of high-rise buildings and also its suitable climate for green wall installation. Green walls typically are classified into two major systems, green facades and living walls. As you can see in this slide, there are some differences in the structure and installation of these types. Traditional green facades are categorized as direct and indirect green facades, while indirect green facades consist of continuous guides and modular trellis. Continuous guides are based on a single support structure that leads plant's direction along the entire surface, while green facades with modular trellises comprise several modular elements and an individual support structure along the surface. On the other hand, living walls are the modern type of green walls for integrating green surfaces in high-rise buildings. Based on application methods, living walls are categorized into continuous and modular. In continuous living walls, which are also known as vertical gardens, plants are inserted in permeable and lightweight screens. However, modular living walls consist of elements with specific dimensions and an intermediate layer for plant growth. Like green buildings and other green-based elements, the adoption of green walls is affected by some hindrances. As you can see in this slide, these hindrances consist of different categories like financial, technical, and legal that we are going to investigate their importance in inhibiting green wall adoption. In our research, in order to prioritize these hindrances, two methods have been employed, namely fuzzy Delphi method and fuzzy parsimonious analytic hierarchy process. Fuzzy Delphi method is an effective approach to identify and refine factors, barriers, criteria in any research, and it usually consists of a single round of survey. It is notable to mention that there are some other methods like enhanced fuzzy Delphi method, which is suitable for a research trying to identify some factors for the first time or where there are limited number of studies have been conducted on its kind. However, in our research, as these hindrances have been already investigated by other researchers around the globe, we have adopted fuzzy Delphi method to refine them based on the opinions of the local experts in Hong Kong. And after that, fuzzy parsimonious analytic hierarchy process is used to rank these barriers. The criteria of being an expert in our research, as you can see in this slide, is to have at least 5 years of related experience in green wall installation and also having at least an undergraduate degree for those who are going to contribute in our research. And in terms of the number of experts, 21 experts have contributed in our research in the first step, which is fuzzy Delphi method, and then for fuzzy parsimonious analytic hierarchy process as recommended by Professor Sadi. 7 experts is enough to ensure a consistent response is achieved. When it comes to fuzzy parsimonious AHP, it's a hybrid method, consists of AHP as a well-known multi-criteria decision-making ranking method, fuzzy set theory, and also parsimonious concept. AHP and fuzzy AHP have been widely used, and also fuzzy parsimonious AHP has been recently developed, and in our research we're going to use all these concepts as a fuzzy parsimonious analytic hierarchy process. The benefit of using parsimonious approach in the analysis is to reduce a considerable number of required pairwise comparisons for the purpose of ranking the hindrances. Also, fuzzy numbers help to achieve a higher accuracy in the results. The results of fuzzy Delphi method show that considering the threshold value, 4 out of 17 hindrances are perceived to be negligible for further analysis in our research. This outcome is based on the experts' opinions on the importance of each of these hindrances in Hong Kong. So 13 hindrances are selected to be analyzed using fuzzy parsimonious AHP. In this slide, it is shown that the number of required pairwise comparisons have reduced by 68. It is notable that using this method requires direct ratings of all 13 hindrances. As a result, instead of doing 78 pairwise comparison, when we just use fuzzy AHP, we have to do this. Instead of doing these 78 pairwise comparisons, we do only 10 pairwise comparisons plus 13 rating that are required to be done. And this makes this method a very efficient one because the number of doing pairwise comparison, which is a difficulty in conducting this method, is significantly reduced. And it is notable that the higher the number of factors or hindrances, the more beneficial parsimonious concept would be in these kinds of analysis. As it can be seen, the final rankings show the importance of financial hindrances followed by technical aspects of green wall installation as the most important hindrances to the adoption of green walls in Hong Kong. Finally, it was concluded that in order to promote the adoption of green walls in Hong Kong, the priority should be given to financial aspects which can possibly be addressed by considering or increasing some financial incentives for green roof installers provided by the government, and also addressing the issues of installation, maintenance, and cost uncertainties relying on technological innovations. Thank you very much for watching my presentation.